this video, we're going to use DeMoivre's theorem to raise a complex number to a power, and also to take a square root of a complex number. Recall that DeMoivre's theorem states that if you have a complex number in polar form, z equals r cosine of theta plus I sine of theta, then z to the n power is going to be r to the n power, then cosine of n times theta plus I sine of n times theta. So let's do our first example. Find one plus I to the 10th power. Our first step is to convert our complex number into polar form. So here 1 plus I is our a plus bi. So 1 plus I is our a plus bi, our complex number in standard form. The formula for r, recall that the formula for r is the square root of a squared plus b squared. So in this case, that is the square root of 1 squared plus 1 squared, which turns out to be the square root of 2. Now, to see what the angle theta is, we should plot our complex number on the complex plane. So let's do it right here. Here is our real axis, our imaginary axis. The real part in our complex number is 1, and the imaginary part is also 1. When we plot our complex number, we realize that the angle theta is 45 degrees or pi over 4 radians. Okay, so let's write our complex number in polar form now. So z is r, which is the square root of 2, multiplied by the cosine of pi over 4 plus I sine of pi over 4. Now we use our formula to obtain z to the 10 power, which is what we're looking for. So our formula says take r, raise it to the n, in this case root of 2 raised to the 10, multiplied by cosine of n times theta, which in this case is going to be 10 times pi over 4, cosine of 10 times pi over 4 plus I sine of 10 times pi over 4 Now we wish to simplify 10 times pi over 4, so let's do it here on this side. 10 times pi over 4, the 10 and the 4 cancel. 10 divided by 2 is 5, 4 divided by 2 is 2. So we end up with 5 pi over 2. 5 pi over 2 pi over 2. Excuse me. Okay, so let's change this to our simplified answer. For 10 times pi over 4, we're changing it into 5 pi over 2. To finish our solution, we would like to simplify this result to get back our answer in standard form. Our question was asking to raise the complex number 1 plus I to the 10th power. That was in standard form. I want my answer also in standard form. Now, observe that the square root of 2 to the 10th power is the same as 2 to the 1/2 raised to the 10th power, which is 2 to the 5. 2 to the 5 is 32. So the square root of 2 to the 10 becomes 32. So we have 32. Now, cosine of 5 pi over 2, that's going to be the same as the cosine of pi over 2. Why is that? If you're on the unit circle and you rotate 5 pi over 2 radians in the positive direction, so pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2, 5 pi over 2, that's the same as the cosine of pi over 2. And we know that that's 0. Plus I sine of 5 pi over 2, which is the same as the sine of pi over 2, and we know that the sine of pi over 2 is 1. So we end up with 32 times 0 plus I. That is the same as 32i. Okay, so here's our answer. 1 plus I to the power 10 equals 32i. Our second example is find the square root of 1 plus I square root of 3. Square root of 1 plus I square root of 3. That is the same as finding 1 plus I square root of 3 raised to the power 1/2. The audience can take a minute to obtain the polar form of 1 plus I square root of 3. I found it to be the polar form of I plus I square root of 3. I found it to be 2 times the cosine of pi over 3 plus I sine of pi over 3. Remember, we are raising this number to the 1/2 power. DeMoivre's theorem says that when I take r cosine theta plus I sine theta, I'm going to get let me repeat that. When I take r cosine of theta plus I sine of theta and I raise it to the power n, I get r to the n cosine of n times theta plus I sine of n times theta. So let's do that. So I have my r is 2, my n is 1/2, then cosine of n theta, so 1/2 times pi over 3. 1/2 times pi over 3 is the same as pi over 6. Plus I sine of the same thing. N times theta is 1/2 times pi over 3, which is pi over 6. Okay, so I am done obtaining my square root using DeMoivre's theorem. I want to present my answer in standard form. So I want to calculate cosine of pi over 6. I want to calculate sine of pi over 6. Now, 2 to the 1/2 is the same as the square root of 2. Cosine of pi over 6 is the square root of 3 over 2. Plus I times sine of pi over 6, which is 1/2. To finish the job, I distribute the square root of 2. Square root of 2 times square root of 3 becomes the square root of 6. So we get the square root of 6 over 2 plus I times square root of 2 times 1 in the numerator is square root of 2 and the denominator is 2. So there is my result. The square root of 1 plus I square root of 3 equals the square root of 6 over 2 plus I square root of 2 over 2. Okay, that's all for now.